Hello everyone, I am Yuvraj Dusunge from Pimpri-Chinchwad College of Engineering, Pune. Today, under the guidance of Shweta Devdas ma'am, I am going to explain the topic multiplexing and demultiplexing in data communication. Before understanding multiplexing, think about this simple situation. Suppose many people wants to travel using only one road. If every person gets a separate road, it becomes expensive and difficult to manage. Similarly, in communication system, instead of using separate channel for every user, multiplexing allows multiple users to share a single communication channel efficiently. In this presentation, we will learn what multiplexing is, how mux and demux works, different types like FDM, TDM, and WDM, their advantages and applications. So let's us start with the basic concept of the multiplexing. Now let us understand what multiplexing actually means. Multiplexing is a technique where multiple signals are combined together and transmitted using one communication channel. The main purpose is to save bandwidth, reduce cost, improve communication efficiency. Now observe the two important devices shown here. The first device is a mux or multiplexer. The job of the multiplexer is to combine many input signals into one output signal. It is always placed at the sender side. The second device is the demux or the demultiplexer. The demultiplexer performs the opposite operation. It separates the combined signal into individual signal at the receiver side. So we can simply say that mux combines signals and demux separates the signals. Let us now understand working process step by step. Here we can see four channels entering the multiplexer. These channels may belong to different user or devices. The multiplexer combine all the signals and send them through a single shared communication channel. Now at the receiver side, the demultiplexer receive the combined signals and separate them it back into the original channel. Because of this process, multiple user can communicate at the same time using only one communication medium. This technique is widely used in internet communication, television broadcasting, and mobile network. Now let us study the first type of multiplexing called frequency division multiplexing or FDM. In FDM, the total bandwidth is divided into different frequency ranges. Each signal gets its own separate frequency band as shown in the diagram. Signal 1 uses frequency from 100 to 200 Hz. Signal 2 uses 200 to 300 Hz, and similarly for the remaining signals. All signals are transmitted simultaneously. Now, one important concept here is guard band. Guard band are small unused frequency spaces placed between channels to prevent interference between signals. FDM is mainly used for analog communication system. Example includes FM radio, cable TV, ADSL internet. Now let us understand time division multiplexing or TDM. In TDM, instead of dividing frequency, we divide time. Each user gets a specific time slot to transmit data. As shown in the figure, slot A, slot B, slot C, and slot D are transmitted one after another repeatedly. Now, TDM is of the two types. First type is synchronous TDM. In this method, every device gets a fixed time slot even if there is no data to send. This makes the system simple, but some bandwidth get wasted. The second type is statistical TDM. Here, time slots are given only when data is available. This method improves efficiency and reduces wastage. TDM is commonly used in digital television system, GSM, mobile communication, and internet network. Now let us move to wavelength division multiplexing or WDM. This technique is used in optical fiber communication. In WDM, different light wavelengths or colors are used to carry multiple signals through a single optical fiber. As shown in the diagram, different colors such as red, orange, green, blue, and violet represent different wavelengths. The optical multiplexer combines these light signals into one fiber cable. At the receiver side, the optical demultiplexer separates them back into individual signals. One advanced version called DWDM or dense WDM can carry more than 80 channels on a single optical fiber. This is why WDM is considered the backbone of the modern high-speed internet communication. Now let us compare FDM, TDM and WDM. FDM divides communication using frequency, TDM divides communication using time slot, WDM divides communication using wavelength of the light. FDM is mainly used for analog system, TDM is used for digital communication system, WDM is used in optical fiber communication. Among all three techniques, WDM provides the highest data carrying capacity, but it is also more expensive. Now let us discuss the advantages of multiplexing. The first advantage is cost efficiency. Since multiple users share one communication channel, fewer cables and devices are needed. The second advantage is better bandwidth utilization because the communication channel is fully used. Another advantage is high throughput because multiple signals travel simultaneously. Multiplexing also improves scalability because more users can be added easily. Finally, it supports efficient long distance communication. Along with advantages, multiplexing also has some disadvantages. One major issue is crosstalk, where signals interfere with each other and create a noise. Another limitation is hardware complexity because additional mux and demux devices are required. In TDM system, synchronization is very important. If sender and receiver timing do not match, error may occur. In synchronous TDM, bandwidth may be wasted because empty time slots are still reserved. Finally, WDM systems are expensive because they are required optical devices such as laser. Now let us see some real world application of multiplexing in broadband internet services. ADSL uses FDM, fiber optic internet use WDM, television network use TDM to carry multiple voice channels. Radio and television broadcasting use FDM, modern 4G and 5G mobile network use OFDM, which is an advanced form of FDM. Satellite communication system use both FDM and TDM. Fiber optic backbone network use DWDM technology to transfer huge amount of the internet data worldwide. So let us summarize today's topic. Multiplexing is a communication technique that allows multiple signals to share single communication channel efficiently. Different multiplexing techniques work differently. FDM uses frequency, TDM uses time slot, WDM uses light wavelengths. The multiplexer combines signals at the sender side while the demultiplexer separates them at the receiver side. Multiplexing is one of the important technologies used in modern communication systems such as internet networks, mobile communications, satellite system, and optical fiber communication. Thank you everyone. I hope the concept of the multiplexing and demultiplexing is now clear. Now let us look at some questions on multiplexing. First, for transmitting 100 TV channels through a single cable, the best technique is frequency division multiplexing or FDM. In this method, each channel is assigned a different frequency so all channel can be transmitted simultaneously without interference. Second, in time division multiplexing or TDM, for users share the same channel using different time slots. Each user sends data in their assigned slot one after another, and the cycle repeats continuously. So FDM divides by frequency, while TDM divides by time. Thank you.